Hey guys, we're going to talk a little bit more about substitution and look at a few different kinds of systems of equations that we're going to be dealing with. So the first thing we're going to look at is when one or both of the equations are not solved for y. And then the second thing we're going to look at are different kinds of special cases. One where there will be no solution, and then others that have infinitely many solutions. So let's first cover when one or both equations are not solved for y. So far we have looked at, I should have done this before, 1 second, I'm going to pause. So far we've only looked at equations, at systems of equations that are like this, where both of them are equal to y. And then it makes it really easy to just see that I can replace this whole piece into here and set up and solve the equation. So let's just do that together. So I'm going to, again, take this whole expression, which is equal to y, and I'm going to plug it into my second equation for y. So that gives me 4x plus 8 equals 5x plus 8. And then what I need to do from there is solve for x. So to solve for x, I need to move my terms that have variables. I need to move them onto one side of the equal sign. And then I need to move my constant numbers to the other side of the equal sign. So I am going to move my 5x over here to be with my 4x. And I'm going to move this 8 to be over here with that 8. So what I need to do to move this 5x over here is I subtract 5x from this side because I have a positive 5x here. So subtracting 5x is going to leave me with 0. But if I subtract 5x from this side, I also have to subtract 5x from that side. 4x minus 5x is negative x. And then still my 8 is over here, my equal sign, and then I still have a positive 8 over there. But now I want to move my 8 to be over onto the right side of the equal sign. So I'm going to subtract 8 from this side, which means I subtract 8 from that side. And over here I'm left with negative x. And again, 8 and negative 8 cancel out to be 0. And that equals 0 plus 8 minus 8. Well, 8 minus 8 is another 0, so I just get 0 over here. And therefore, if negative x is equal to 0, positive x is also equal to 0. So that's my value for x. And then I need to plug it in to one of these two equations in order to solve for y. So let's use that first equation, y equals 4x plus 8. This time I'm going to substitute 0 in for x. So I get y equals 4 times 0 plus 8. Y equals 4 times 0 is 0 plus 8. 0 plus 8 is just 8. So y equals 8. And now the checking part. So you always have the ability here to check your work without even talking to me or anyone else. You can go ahead and check your answer. So what I do is I take those two equations and I'm going to plug in 0 for x and 8 for y and check to see if I'm right. So I'll write my two equations down. Y equals 4x plus 8 and y equals 5x plus 8. I'm going to plug 0 in for x, 8 in for y. So I get 8 equals 4 times 0 plus 8. And therefore 8 equals 0 plus 8, which is true. Excuse me. And then the other one, again, I plug in 0 for x, 8 for y. And I get 8 equals 5 times 0 plus 8. Therefore, 8 equals 0 plus 8. Yes, that is true. So I know that both of those equations are satisfied by x for 0 and y for 8. And I write my answer like this in an ordered pair, where x comes first and then y, and that's that. But now we're going to talk about when we don't have equations that look like this, when the first step involves us moving equations around and then solving and then plugging back in and solving again. So it adds just another layer to that. Give me 1 second and we'll go over a couple of those. Hey guys, we're going to talk about these two different kind of variations on systems of equations. So far all we've looked at are equations that are like this. We have two equations and they're in slope-intercept form. So we have y on one side and then the rest of the expression on the other side. So it'll be, you know, ax plus b and let's say dx plus c. And then we can just set those two pieces equal to each other and go on our merry way of solving for the variables. However, we don't always have equations that look like that. Sometimes we'll have equations that are in standard form or in point slope form or in some other kind of form. And so in that case, it's going to look a little bit different. So I want to show you how to do that. So in this system of equations, my first equation is written in standard form, and my second equation is written in slope-intercept form. So one of the equations is solved for y, and the other one is not. So this time it's not quite as easy as just setting this side equal to that side or something. But we do get lucky in having one of the equations set equal to y. And we're lucky because we can take this expression, the 8x plus 21, that part is equal to y, so I can plug that in to this y up here. Okay? So I'm going to show you what that looks like. What I'm going to do first is rewrite this first equation, the 7x minus 3y equals negative 12. And then I'm going to rewrite it with 8x plus 21 substituted in for y. So I get 7x minus 3 times 8x plus 21 equals negative 12. And now I can just go ahead and solve for x. First thing I need to do is distribute. I distribute that 3 across the 8x and the 21. So I get 7x, and then negative 3 times 8x is negative 24x. And then negative 3 times 21 is negative 63. And that all equals negative 12. Now I can combine like terms. So 7x minus 24x gives me negative 17x. Minus 63 equals negative 12. Now I want to move this 63 to be over here with the 12. So in order to do that, since I'm subtracting 63 on this side, I need to undo that operation, which means I need to add 63. I do plus 63, which means I also need to add 63 over here. Combine those two lines, I get negative 17x. The 63's cancel out. That just equals 63 minus 12, which gives me 51. Now, since there's a multiplication going on between the negative 17 and the x, in order to undo that operation, I need to divide. So I divide by negative 17, divide by negative 17. These negative 17s cancel out, and I'm left with just x, and that should be equal to negative 3. Negative 3. Now what I can do is I can plug this back in to either one of these equations and find the value of y. I can see pretty easily that it's going to be a lot easier to plug in negative 3 for x in this second equation than in the first equation. So that's what I'm going to do. I'm going to use this equation, y equals 8x plus 21. I could use that one if I wanted, but I think this one's going to be easier. So that's the one I'm going to use. So I plug in negative 3 for x up here, which gives me y, let's see, can I show them differently? Y equals 8 times negative 3 plus 21. So y equals 8 times negative 3 is negative 24 plus 21. So y equals negative 3. So y should equal negative 3 and x should equal negative 3. We can check our work by plugging those values in to the original equations. So I'm going to plug in negative 3 for x, negative 3 for y. Let's look at that first equation. So 7x minus 3y equals negative 12. Plug in negative 3 for x, so I get 7 times negative 3 minus 3 times negative 3 equals negative 12. 7 times negative 3 is negative 21, minus 3 times negative 3 is negative 9, equals negative 12. Negative 21 minus a negative 9 is really like negative 21 plus 9, which, yes, does equal negative 12. So we know that works in this equation. Let's try our second equation. Y equals 8x plus 21. I sub in negative 3 for y. So negative 3 equals 8 times, I sub in negative 3 for x. So 8 times negative 3 plus 21. Negative 3 equals negative 24 plus 21. Yes, that is true. So my solution is negative 3, negative 3. I write that as an ordered pair where x comes first, y comes second. Right? So now let us look at this one where both equations are not solved for y, both. So it's not very easy to tell what one variable equals in this case. Up here, no, whoops. Sorry about that. Let's refocus. So up here, one of our equations was set equal to y. So it was easy to just plug this in for the value of y. However, down here, we don't have that. We don't have that. It's harder to see. So what we can do, what we want to do, is first solve for y in one of those equations, and then go back and plug it in. Just taking a look at these different equations, I'm going to see it's much easier to solve for this y down here than it would be to solve for this x or that y. So I'm going to go ahead and do that. I'm going to rewrite this second equation. 2x plus y equals negative 3. I'm going to subtract negative 2x over here, which means I subtract negative 2x over there. Combine those two lines together. Those two x's cancel out. I'm left with just y equals negative 3 minus 2x. I can't combine those two together because they're not like terms. However, I can list it like that, where it's just an expression, -3 minus 2x. And that is equal to my y. So now I can take this and I can plug it in to that other equation. I can plug that in for y. So I'm going to use this other equation, -x plus 8y equals 10. Plug in -3 minus 2x in for y. So I get -x plus 8 times -3 minus 2x equals 10. Now I solve like regular, solving for x. First thing I need to do is distribute. So I get -x plus 8 times -3 is -24. And then 8 times -2x is -16x. And that equals 10. Now I combine like terms. So I combine the -x and the -16x. And then I'll just leave my -24 and my 10 alone for now. So -x and -16x gives me -17x minus 24 equals 10. Now I need to move my terms around so that all my terms with a variable are on one side of the equal sign and all my constant terms are on the other side of the equal sign. So what I need to do is move this -24 over to be with the 10. So since I'm subtracting 24 on this side, in order to undo that, I need to add 24. If I add 24 over here, then I add 24 over there. Combine these two lines together, and I get -17x. These guys cancel out, and I'm left with 10 plus 24, which is 34. And then I need to undo this multiplication going on between the -17 and the x. So I undo by dividing. I divide by -17, which means I divide by -17. These guys cancel out. I'm left with just x equals 34 over -17, which is -2. So that's my answer for x. And now I can go back and I can plug that in to one of my original equations and then solve for x. So I'm going to plug it in to this equation we came up with, y equals -3 minus 2x. So I get, let's rewrite it, y equals -3 minus 2x, plug in -2 for x, which gives me y equals -3 minus 2 times -2. Y equals -3, and then minus 2 times -2 is -4. So since I'm subtracting a negative, it really means that I'm adding. So that becomes -3 plus 4, which equals 1. Now I want to plug these two values into both of these equations and check my work. So first, I write out my first equation, -x plus 8y equals 10, and I plug in -2 for x, 1 for y. So I get -2 plus 8 times 1 equals 10. Double negatives here become a positive, so that's just 2 plus 8 times 1 is 8. And yes, that does equal 10. Now my second equation, 2x plus y equals -3. Plug in -2 for x, 1 for y, and I get 2 times -2 plus 1 equals -3. 2 times -2 is -4 plus 1. Yes, that does equal -3. So we're right, and that means that -2 is my value for x, 1 is my solution for y, and I can write that solution as an ordered pair. Remember, x comes first, y comes second, So I write my solution as -2, 1. And that's my answer. There it is, -2, 1. Okay, now what we're going to do is look at some special cases. So remember, when we're solving systems of equations, what we're looking at are two different equations, and we're looking for where they intersect. We're looking for where both equations will be equal, where the same values for x and y will make both equations true. On a graph, again, that looks like the intersection of the two lines. So what happens if I have something that looks like this, where I have two parallel lines, where the two lines never ever intersect? Or what happens when I have the same line? What happens when I have the same line? These are what we're going to call our special cases. This first one, when we have parallel lines, there's going to be no solution. There's going to be absolutely no possible values that we can plug in for x and y that will make both equations true. This example where we have two different lines that are exactly the same line, those are going to have infinitely many solutions. You can pick, there's an infinite amount of values you can choose for both variables that will make both equations true. I'm going to go through what that's going to look like when we're solving algebraically, when we're solving using either substitution or elimination. Right, let's do this first one. So since neither of my equations here are solved for y, my first step needs to be solving for y. So I can see that I'm able to solve for y pretty easily in this second equation. So that's the first thing I'm going to do is rewrite this equation. -5x plus y equals -3. Since there's a -5x on this side, in order to move it over here, I need to do the inverse operation. So I need to add 5x over here, which means I add 5x over there. Then I combine those two lines together. -5x and +5x cancel out to be 0. I'm left with y equals -3 plus 5x. Now that I know my value of y, I know it's equal to this expression, I can plug that in to my first equation. So for 5x minus y equals 7, I'm going to plug in -3 plus 5x in for y. So I get 5x minus -3 plus 5x equals 7. So now I'm going to distribute this -1 to the -3 and to the 5x. So I get 5x, -1 times -3 gives me +3, and then -1 times 5x gives me -5x, and that all equals 7. Now I'm going to combine like terms. So I can combine this 5x and that 5x, and then the 3 and the 7 are going to remain on their own for now. When I subtract 5x from 5x, when I do 5x minus 5x, I get 0. And then that 3 stays the same, and I'm left with that equal to 7. 0 plus 3 is just equal to 3. 3 equal to 7. And this is where I notice something's up, because 3 does not equal 7. 3 will never, ever equal 7. So when something like this shows up, when I have two numbers set equal to each other that are not equal to each other, that means that there is no solution. So the answer to this, when someone says, okay, solve this system of equations, you get to this point, and then you realize there's no solution. So our answer is no solution. Right, and now let's look at the other special case, infinitely many solutions. So again, this is when we have the same exact line. And that's an important piece to realize, is that the same line can be written a whole bunch of different ways. So it's not always easy to just look and spot and say, oh, these are the same thing, because they look different. However, when we graph these, they would come out to be the same. And you'll see how we know that. So since one of my equations is set equal to y, I am able to plug this expression in for y in the second equation. So I'm going to rewrite this second equation. It's negative 4x plus 2y equals 38. I'm going to plug in that 2x plus 19 in for y. So I get negative 4x plus 2 times 2x plus 19. And that equals 38. Now I get negative 4x, and I'm going to distribute. So 2 times 2x is 4x. And then 2 times 19 is 38. And that equals 38. Now, negative 4x plus 4x gives me 0. 0 plus 38 equals 38, which 0 plus 38 simplifies to just 38. 38 equals 38, which is always going to be true. Always, always. 38 equals 38. 2 equals 2. Always. That tells me that there are infinitely many solutions. And so my answer to this problem, when I'm asked to solve for this system of equations, my answer is that there are infinitely many solutions. So just to go over that again, when we get something that's like this, that's two numbers equal to each other that are not equal to each other, 3 equals 7, or maybe it's 1 equals 52, or 3 equals 13, or anything like that, when there's two different numbers on either side of the equal sign, there is going to be no solution. And that's how you write that. That's what that symbol means. No solution. And then when we have something that looks like this, where it's just two numbers on either side of the equal sign, there's no x anymore. Same up here, there was no x anymore. But when this is true, when it's 38 equals 38, or 1 equals 1, or 52 equals 52, or 3 equals 3, whatever, when it's the same number on both sides, there is going to be infinitely many solutions. And that is how you write that out. Just write it out. Okay? I'm going to give you guys some practice problems to work through systems of equations like this. And that is going to be your last assignment for this week. All right? Thank you for watching. If you have questions, please let me know. I hope you're having a great day. And if I don't talk to you again, happy Thanksgiving.